My name is Rama Darbha. I am a senior consulting engineer here at Cumulus Networks.
In this video, we'll be discussing how to configure BGP unnumbered. BGP unnumbered is a new innovation that Cumulus Linux has introduced into the networking landscape. It is an extension of RFC 5549 that allows IPv4 addresses to be advertised over IPv6 BGP neighbor peering. BGP unnumbered leverages the IPv6 link local addresses on two adjacent switches to build a BGP neighbor relationship. The IPv6 neighbor peering is then used to exchange both IPv6 and IPv4 routes. BGP unnumbered, as the name states, does not require IP addresses on the interfaces to build BGP peers. Instead, it leverages the interface itself to peer with the neighbor physically connected to the link. BGP in the data center allows for greater scalability, flexibility, and control. As such, the BGP configuration needed to evolve to handle the requirement of the data center. BGP unnumbered simplifies the BGP configuration and is perfectly suited for the data center use case. The BGP unnumbered configuration is more attuned for automation and reduces the need for IP addressing and AS numbers in peering as BGP is enabled on the interface itself. As you can see in this example, the router ID and the local ASN are the only two configuration points needed. The IP address neighbor, as well as the remote AS that is configured historically, is now replaced with just the interface and whether the remote peer AS is an external eBGP connection or an internal iBGP connection. In this demo, we will configure BGP unnumbered between a spine and the leaf. On the left-hand side, we have the spine, and on the right-hand side, we have the leaf. To start off, first we will configure the loopback address on the actual spine itself. Then we will configure the BGP router instance with the local AS. Now we will assign the router ID to match the loopback itself. And now, as the final step to build the entire peering, we will configure the interface between the spine and the leaf to be a BGP connection. Now, once those configurations are done, we can commit our changes. Now, similarly, we will do the same thing on the leaf. First, we configure the loopback address to be its own unique address. Then we create the BGP router instance to be a unique local AS number. We assign the loopback address to be the router ID. Now we configure the BGP peering. And as you can see, we have picked the remote AX to be external in each case because the two ASNs are different and we are using an eBGP connection. Now once that is done, we can commit the changes. And now that we have both the spine and the leaf configured, we can go ahead and check to make sure that the peering is up. As you can see, the BGP peer between leaf 01 and spine 01 are both successfully up and exchanging information. So to summarize, the final configurations for this demo are available on the screen currently. As you can see, the amount of configuration is incredibly simple, and as you scale this, each additional peer only needs to be assigned via one additional command, assigning the interface that the peer is connected on. BGP unnumbered is an ideal use case for the data center as it allows for simplification of your configuration, which leads to allowing for automation and higher levels of efficiency and productivity. Thank you for listening to this video series, and we hope that you enjoyed hearing and learning about how to configure BGP unnumbered.